Hi there, everybody. Welcome to another Suricata webinar. This is the first PreSuriCon webinar of the season. I'm Juliana Fajartini. I'll be your host. Together with me, I have our Executive Director, Kelly Misata, and our wonderful speaker who took time to be with us today, Soner Tari. And without further ado, welcome everyone. Let's get started. I hope everyone can see my screen all right. As I said, this is the first webinar for getting everyone hyped for Suricon in Montreal this year. Before we get started with the webinar per se, just a few words about OISF that helps us exist. OISF stands for Open Information Security Foundation. We are a US-based nonprofit that are organized to build community and support open source security technologies like Suricata. Funding for our project comes from donations from world-class security organizations committed to our mission. If you would like to know more about our consortium members or become one, do check our consortium members page, that is oisf.net/consortium. Here you have pictures of our amazing team and some of our past outreach interns who are very dear to us. If you joined us today and don't know what Suricata is or have only heard a few words, let us just introduce it by saying that we are an open source IDS, IPS, NSM, meaning that we do network analysis. We generate logs based on rules, but also without rules, logging protocol transactions, network flows. We record traffic conditionally or not, and we extract files from transactions. This can be done on the cloud and on-premise. And this means that you can keep your network protected, your environment protected, but also generate data that could be used, for instance, with an LLM to do more adaptive analysis. So this is us. Today we have, as I've mentioned, Soner Tari. He is a long-time open source maintainer and contributor. I will let him speak about himself a bit more, but we are very happy to see someone who also works with open source here today. Soner, thanks a lot for being here today with us. I'll stop sharing. The floor is yours.
Thank you, Juliana. Okay, let me share my desktop and let me use entire screen. So I hope you can see this.
Yep.
So yes, just like Juliana said, I'm a software developer, and all of the projects I have on GitHub are on cybersecurity, and they complement each other. And especially the ones I'm going to talk about in today's presentation will be SSL proxy and my UTM firewall project, which I started in 2006, and it was called CommXWall back then. In this presentation, I'll be talking about how we can inspect encrypted traffic using especially Suricata and SSL proxy, and I'm going to propose something new. I'll propose that we can use perhaps the standard ICAP protocol. And this presentation is based on my 3-part LinkedIn series, article series. You can find it at this link. By the way, you can find this presentation in my repost at LinkedIn of this webinar. And I also replied to Juliana's announcement about this webinar. You can find the link to this, to the slides of this presentation as well. So let's get started. First, the contents. I'll talk about encrypted traffic and how we can feed it and passive IPS, and then I'll say we need active inline IPS, and we'll get a bit more technical, and I'll talk about SSL proxy and my first attempt with Node preprocessor and how we can preserve network context. There are a couple of possible solutions, and then I'll talk about my proposal, and I'll propose a roadmap for it. So yeah, I mean, in early 2000s or mid 2000s, we actually didn't have too much encrypted traffic. It's back then, for example, we were using Telnet instead of SSH. But it's 2025 and it's omnipresent and we cannot live without it. In fact, that's amazing. It's perfect for regular users. But for the developers of tools like SSL proxy, it's a pain, of course, as you can imagine. And 90% of all internet traffic is encrypted now. Well, it seems without decryption, what you can do is shallow inspection, but it's quite limited. And especially these days, we have encrypted SNI and encrypted client hello. So all you can do is probably inspect the IP address and port numbers. And it gets even worse because cyber threats are hide within the payload. In fact, 85% of threats are in the payload. There's nothing shallow inspection can do about that. So as you can see, we actually need decryption. We need to inspect the contents, and to do that, we need to decrypt the encrypted traffic. And this is true for both rule-based systems like Suricata and AI-based tools. Because how can you even train an AI tool with encrypted traffic? And when you think about it, in modern cryptography, if you feed the same content to OpenSSL, for example, and encrypt it twice, you get two different outputs. So there's no way you can train an AI tool to detect patterns in encrypted traffic. But it's not without issues. I'm going to talk about further issues with SSL inspection. What we're talking about is called actually SSL inspection. And here I want to talk about, for example, certificate forging. To decrypt traffic, we have to perform a man-in-the-middle attack. To do that, you need to forge server certificates. And for this purpose, you need a CA certificate you use with, for example, SSL proxy. And you have to install it into the trust stores of all the devices behind SSL proxy. Okay, you can do that because that's what system admins always do. But then we have certificate pinning. In certificate pinning, they hard code the server certificate into the application. Because of that, this is usually used in smartphones. It is extensively used in smartphones and that's a problem for SSL proxy kind of tools. But still, you cannot use this technique in browsers. So even though there are many network and system administrators who are against SSL inspection, it's not like SSL proxy is useless. And it's true that there is some validity in those claims. It's true that its configuration is, SSL inspection configuration is a bit complicated. In fact, for example, for certificate pinning, you have to bypass those traffic through SSL proxy. So, and SSL proxy supports powerful filtering rules. But this also means that you need a whitelist and you have to maintain that whitelist. And there are other configuration options as well. So yeah, I mean, it's problematic for network and system administrators. They sometimes say it causes more trouble than it solves. But like I said, it doesn't make SSL proxy useless or similar tools useless. And again, like I said, for deep content inspection, you have to decrypt encrypted traffic. So in the rest of this presentation, I will assume we all want SSL inspection. And we have decrypted encrypted traffic. So how do we feed it to our IDS systems? There are two basic options we can use. The first one is PCAP files. In fact, SSL proxy supports that. There are these -X and -Y and small y options. I think the first one is the single PCAP file, the other is the directory, and the other one is pattern substitution. So SSL proxy decrypts the packets and writes into PCAP files. Does Suricata support it? Of course it does. With the -R option, you can feed your PCAP files to Suricata. In fact, there is this long form PCAP file options. I think it's PCAP file delete, PCAP file continues, which help with the PCAP file management. So it is possible. SSL proxy records, Suricata reads, and that way you feed your traffic, decrypted traffic into your IDS system. There's a second option, which is called the mirroring option in SSL proxy. As I said, SSL proxy supports it with this -I. So it mirrors the packets to decrypted packets to an interface. And you can use an L2 address as well. Does Suricata support it? Of course it does, with the -I option. SSL proxy listens on the mirrored interface in promiscuous mode, and you're done. And this is not theoretical because, as you can see, there's a link here. There's a sample implementation. This is a bachelor's thesis by a Czech student. And he uses exactly what I just told you. He uses Suricata with SSL proxy, and he's able to generate alerts. Okay, so is there any issues with these options? Unfortunately, yes. First of all, performance overhead. There's significant I/O and network overhead, emulation overhead, and this is on top of the cost of decryption. Also, there are scalability and management issues. For example, you have to rotate the PCAP files. You have to manage storage. Okay, I mean, let's say you're trying to find solutions to that, but then let's assume SSL proxy is faster than Suricata. So you get PCAP buildup. If Suricata is faster than SSL proxy, then you're going to get just one PCAP file, and that's going to cause concurrency issues. Of course, you can work around these issues. I know there are people who solve these issues, but there are workarounds actually. Is there any problem with the packet emulation, the mirroring option? Yes, because it's similar to the span port of managed switch. You know, span ports start dropping packets if the data rate is very high. And in this case, if we get packet loss, I really don't know what happens. And I don't know what Suricata does if there's too much packet loss. So at high data rates, can we keep up with the wire speed? That's a natural question. And if you ask me, these approaches seem more suitable for offline analysis. But okay, are we done yet? Nope. Because to achieve a passive intrusion prevention system, first of all, you have to follow those alerts you generate. And then you have to inject blocking rules into your packet filtering system. But you shouldn't block those IP addresses indefinitely. You need to block them for a period of time, for example, for 60 seconds. And this is not something a human should be doing. You should automate this process, this reactive process. Do we have a solution? Of course we do, as you can expect. I have another project called Soner IPS. I should actually call it passive IPS because it supports Suricata as well. Because Soner and Suricata loads are quite similar. It successfully runs on my UTM firewall project, and you can find it at GitHub. On top of the issues I just mentioned before in the previous slide, there are further issues with this reactive solutions. First of all, it's asynchronous. What we mean by asynchronous is that the detection and response are not in synchrony. And it's slow. You have to decrypt, process, analyze, generate alerts, follow, and then inject rule. And by the time you do that, by the time you inject a rule, the malicious connection has probably already traversed the network. So that's why we say breach occurs first. So the system detects a breach after it has already happened. This doesn't mean that, I mean, this is not good. I mean, it's better than doing nothing. But as you can see, we can, and we should do something better. Can we do something better? Of course we can. And you guys are experts on this. So this is called active inline IPS. And it provides proactive prevention. First of all, it's synchronous, it's real time, it's proactive prevention because we block instantaneously at the point of detection. Then that provides synchronicity here. And that's the exact definition of active inline IPS. Are there any solutions like that? Of course there are, but most of them are, unfortunately, currently commercial and closed source solutions. What is the first alternative that comes to mind in terms of open source solutions? It's OpenSense. But unfortunately, it uses an armor, which is a commercial closed source solution again. So I've been searching to find any other solution which is fully open source, next generation firewall with active inline IPS support with SSL inspection support. Unfortunately, it's only my UTM firewall project with SSL proxy, which is a shame, because the natural question right now is open source falling behind? And actually, this is a rhetorical question because it's falling behind. It's obvious. And as I promised, I'm going to talk about further issues with SSL interception. There are further issues, and it's closely related with the commercial closed source solutions. In fact, there is this. This is a link to another presentation of mine from 2018, and there I talk about risks of SSL interception. There's a specific slide where I actually copy paste from a paper at the top. I mentioned the paper. There's a table here with, I think there are 12 commercial firewalls, middle boxes. But unfortunately, as you can see, except for blue codes, the rest, half of the rest get F, failing grade. The other half gets C. There are vulnerabilities. They downgrade the connection strength. They use weak ciphers, lots of other issues. And probably they have solved all of these problems in the past 7 years, since 2018. But this doesn't change the fact. I mean, think of this like that. Cryptography is important, and all cryptographic algorithms, as far as I know, cryptographic ciphers, they're all open source, and that's for a reason. And we're talking about SSL inspection, and you can think about it as a continuation of cryptography. So it's quite natural to expect open source solutions. So in the rest of this presentation, I will assume that we all want SSL inspection, and we all want open source solutions for SSL inspection, especially in terms of active inline IPS topic we're talking about here. So let's get a bit more technical. And let me start talking about the existing mode of operation in SSL proxy. You can find this diagram in the README of SSL proxy, by the way. And there's text around it which describe this diagram and how this works. But let me briefly explain how it works. First of all, SSL proxy accepts connection from the client in green, and it decrypts the packet. It starts a new connection on the loopback interface over network sockets to the listener program, the blue box here. Like I said, the keywords are on the loopback interface using network sockets and a new connection. I'll come to that later. And the program, let's say, is a web filter like E2 Guardian. It does whatever web filter does. It filters the contents. It may even respond with a denied page. Or for the sake of this description, let's say it decides to pass the packet with or without modification. So it returns the packet back to SSL proxy. SSL proxy re-encrypts it and sends it to its original destination, the server here in red. When the server replies this packet, the packet follows the same path to the client in reverse order. Now, there are a few things here. Like I said, SSL proxy opens a new connection on the loopback interface. This means that there's no way for the listening program to know the original source and destination addresses. network context is lost. So we have to find a way of passing that info to the listening program. And that's why we have this at the bottom. There's a sample SSL proxy line. That's why I have come up with this solution. The first IP address is actually the return address dynamically assigned for the connection. For each connection, SSL proxy assigns an IP address. In this case, it's the loopback IP address. It doesn't have to be because SSL proxy supports remote listening programs, but you have to be careful about that because the content is decrypted, of course. The second IP address is the original source address. The third one is the original destination address. The last S here is, again, something the listening program cannot possibly know. The original connection was encrypted and we have decrypted it. That's what it says. So before we go to the next slide, I'd like to take your attention to the pinkish orange box here, which says IPS in it. And there are two double arrow connections here. Those are actually over diverged sockets I'm going to talk about in a few seconds. But keep this in mind. That's how we pass the packets to our ITS systems. So in summary, this mode of operation actually works on my UTM firewall project. E2 Guardian supports it by the help of my modification to it, of course, in its source code. And the email proxies on UTM firewall project of mine, the PreSuriCon and SMTP gated. And just to summarize, E2 Guardian listens for connections on a network socket. That's critical. We're going to talk about that. SSL proxy opens a new connection, and that's why we lose the network context, and that's why we need the SSL proxy line. And I have passed the source code of E2 Guardian. So, by the way, the SSL proxy line is in the first data packet and the first data packet only. And E2 Guardian rewrites the source and destination addresses and uses them in its logic and logs. And this works perfectly fine on my UTM firewall project since 2027. It's been 8 years. So can we use this mode of operation with our IDS systems like Suricata? But the keyword is here, like I said. Unfortunately, Snort and Suricata do not support acquiring packets over network sockets for various reasons, technical reasons, of course. You guys know this better than I do. So what can we do about that? First of all, how do we pass the packets to our IDS systems? We use diverged sockets. And in this case, on OpenBSD, we use diverged sockets. I think it's best to describe it using this PF rule on OpenBSD. This is from my UTM firewall project. On the loopback interface, this is what it says. Before you give the packet to the program, in this case, it's E2 Guardian, listening on the network port 8080, before giving it to that, give it to the program, in this case, it's Snort or Suricata, it doesn't matter, listening on divert port 700, and that's it. And this provides us the active inline feature. Because if Snort or Suricata does not re-inject the packet into the kernel, it's effectively blocked. So that's actually what we mean by instantaneous interception, instantaneous blocking at the point of detection. So what we do is my first attempt was that I have developed a Snort preprocessor. By the way, Suricata does not support preprocessors. But I did develop a preprocessor for Snort, which parses the SSL proxy line in the first data packet, and then rewrites the original source and destination addresses, and so that Snort can use it in its rules and logs. By the way, this is very important, rules. This is very critical for any IDS system, because as you know, for example, the most famous variables in an IDS configuration file is external net and home net variables, and they all depend on the original source and destination addresses. So, as I said, the SSL proxy line is in the first data packet. That's why this is called mid-flow address rewriting. But the initial TCP handshake packets still use the loopback IP address. which is confusing. I mean, think about it. Snort has to create an entry in its flow table using this IP address, which is 127.0.0.1. That's supposed to lead potential issues, right? Not all flows, but I've seen some stale flows, which only disappear when they time out or when I terminate the Snort instance. So as you can see, this is problematic. So as a conclusion, I would say that mid-flow address rewriting is not a reliable solution. So we should do something better. Can we do something better? Is there any other possible solution? And the purpose is, of course, preserving the network context, as you know. First of all, we can fully emulate the packets from the start, from the very initial TCP handshake packets. We can use the original source and destination addresses. In fact, this is the solution used by Blue Code SSLBA. I know that Blue Code is now, it's been purchased by Symantec and then it's been purchased by Broadcom, but I don't think they've changed anything in this approach. I'm not sure. I've never used Blue Code before, but they also use magic MAC addresses and special VLAN headers. You guys know this better than I do, I'm sure. And Suricata supports this. This is based on the documentation, not on experience, but I know that it supports. So I don't know how these packets are passed to Suricata. And you have probably noticed that we've already talked about packet emulation in the mirroring feature in SSL proxy. So what is the difference? I'm sure you guys know this better than I do again, but the major difference is that with the mirroring feature in SSL proxy, you can only obtain a passive IPS system, not an active inline IPS system. And I've been watching a few videos, YouTube videos actually, I guess, with the how to configure Blue Code like this. And there are ports and there's also failover, fail open configuration and stuff like that. So I don't know the other details, but the mirroring feature in SSL proxy can give you just a passive IPS. So this Blue Code kind of solution is the first option. There's a second option. We can develop a new data acquisition mode, a new doc module, which parses the SSL proxy line. It would first buffer the initial TCP handshake packets with the 127.0.0.1 the loopback IP address, or actually can trash it. We don't need that. And after it receives the SSL proxy line and the first data packet, it starts emulating all the packets, including the initial TCP handshake packets with the correct network context. This is the main difference between my initial Snort preprocessor method and this new possibility. Are there any issues? As usual, there are. These are not standard solutions. These are custom solutions. They're not based on an open standard. For example, in the case of Blue Code, they use magic MAC addresses. In the case of this SSL proxy new doc acquisition mode, we have this SSL proxy line. So they require vendor-specific integrations. So we need to do something better than this. And we come to my proposal in this presentation. But before we go into the details, by the way, this is a simple solution. And I wouldn't be surprised if I'm not the only one or the first one to propose this. But before that, let me mention this again. The primary goal here is deep content inspection. We're not interested in low-level TCP anomalies. We're interested in the cyber threats hidden in decrypted payload. In fact, when you think about it, SSL proxy cannot do that. I mean, because underneath SSL proxy is the event, and it's running at another abstraction layer. It hides those low-level details from SSL proxy. And this is not specific to SSL proxy, actually. All such middle boxes have the same problem because their primary goal is deep content inspection. And if you're interested in those low-level details and you want to detect those anomalies, an option would be to pass the encrypted traffic, the original encrypted traffic, to Suricata. So what I'm suggesting, you pass the traffic twice, once encrypted, second time decrypted. Okay, let's start talking about my proposal. ICAP, the ICAP protocol, it's a standard protocol for content inspection, actually. That's why I wouldn't be surprised I'm the first one to propose this, because it's being used for virus scanning viruses. So why not? Why shouldn't we use it for intrusion detection? But the standard ICAP protocol does not have any support for network context. So we need to add new headers with the original source and destination addresses. But this doesn't make this a custom solution, because as you know, this is quite customary in HTTP as well, and ICAP is very similar to HTTP. So we can always use such new headers. So we pass the network context like this. We extend the ICAP protocol. So how does it work? The flow is something like this. SSL proxy acts as an ICAP client. It sends ICAP requests to Suricata with those headers, new headers, and the payload, of course. And Suricata acts as an ICAP server. To do that, of course, we need a new doc module, which parses the headers to obtain the network context, original network context, and it starts emulating TCP packets using this original context. But that's to satisfy the reassembly requirements of Suricata. And in fact, that's an issue, because that's an unnecessary overhead. That's just to satisfy Suricata's reassembly needs. I'm going to come to that in the next slide, actually. Why is this better than the other solutions? Because, first of all, it provides a true real-time, active inline, and open source IPS solution. And it uses the standard ICAP protocol. And because of that, it's universally applicable. Any program with ICAP support can use it, not just Suricata or Soner. And it separates decryption from inspection so that they can specialize and operate optimally. I mean, both sides. But of course, like I said, there's an issue. And as a next step, we can perhaps find a way to pass content to Suricata without any packet emulation. So yes, that's a proposal. And do we have a roadmap for this? I think we can implement it something like this. For Suricata or Soner, we can develop a new doc module, which can act as an ICAP server. This will be emulating packets to Suricata, for Suricata. And for SSL proxy, I had to implement ICAP client support in it. But that also means a new mode of operation, separate from the mode of operation I've already talked about using network sockets and the SSL proxy line solution. This also means that I have to modify the syntax in the SSL proxy config files, especially the process specs and filtering rules, because you would like to selectively, use the ICAP support. And I'd like to keep the already existing mode of operation. So the old and new modes should coexist. Now, but to achieve this, I should probably say that, remember that I proposed another doc module, which would be parsing the SSL proxy line and then start emulating. This is quite similar to the solution here, actually. So to really develop this solution, I would first implement that doc module and then add ICAP server support to it to obtain the doc module I'm talking about in this slide. So we can go step by step, and then finally we could probably find a solution to get rid of the packet emulation just to satisfy the reassembly needs of Suricata. So this would be the end of the presentation, but as is customary in this presentation, I can see another issue, and that should be the part of the roadmap as well. There's a hidden challenge: real-time HTTP inspection. Remind you, we've been talking about real-time here all the time, because there are open source solutions for offline analysis. I mean, For example, Wireshark, you can record the traffic in pcap files and open them using Wireshark and do whatever you want, and you can inspect it. We're done, but we're talking about real time. Unfortunately, SSL proxy does not support HTTP2 yet. In fact, most listening programs do not support HTTP2 yet. E2 Guardian, Squid, supposedly Squid supports it, but as far as I know, it's not complete yet. Unfortunately, there are commercial closed source solutions with HTTP2 support. This is very similar to the case with encryption and active inline solution. I've already mentioned that. And to make things work, in 2025, more than 30% of servers on the web now support HTTP2, which doesn't mean that 30% of network traffic is HTTP2 now, but really the blind spot for open source is not just encrypted, but also HTTP2 traffic. And you can find the details in my yet another LinkedIn article. You can find on my LinkedIn profile. And if you're still not convinced that HTTP2 is a problem, I can give you a very specific example. I have yet another LinkedIn article, which is called Modern Ad Block, Network Level Ad Block for my UTM firewall project. I just want to mention something very specific that I don't want to go into the detail, but that article is not actually theoretical. I've already done that. But I did that for a commercial closed source solution with Windows, macOS, and Linux support. In that article, my LinkedIn article, I'm talking about I'm going to develop a solution for my UTM firewall project. But while I was developing that solution, you have to test what you're doing. And for example, there's a website called adblocktester.com, which gives you a mark about your success out of 100. You get points. So I was testing my solution with that. Initially, I hadn't implemented HTTP2. So, for example, on macOS, I was getting strange results, like on Safari, Firefox, and Chromium, I was getting very different results. I was getting 90% success, sometimes 60, 70, and it was always different on different browsers. So I was blaming it on the browsers or temporary connection issues. But after a while, I realized those are not the reasons. So I decided to implement HTTP2 support in the solution. So guess what? I got 100% success in all of the browsers. Safari, Chromium, and Firefox. All the time, all of them. So I think this solid example proves that HTTP2 is here and now, and we have to do something about it. So even if we implement all the roadmap here, I think we have to implement the HTTP2 as well. And I haven't implemented anything yet, so I welcome any suggestions, all questions. You know where to find me. You can ask questions in the Q&A section of this webinar too, but after the webinar, you can send me all sorts of messages about this. And I think this is all I wanted to say. Thank you for listening. Thank you all for listening. And Juliana, back to you.
Thank you. Thanks for the presentation. I really like presentations that share the challenges and the path. So thank you. We have one question so far. It was by my colleague, Philippe Antoine. And he said, I cannot stay until the end, but here is my question. Does or will SSL proxy support QUIC protocol?
QUIC protocol. It's not in my to-do list, actually. But I'll consider adding that. So yeah, quick answer. Not yet.
All right, thank you. Folks, do you have more questions? People from the team, or anything to add? Victor Julian is saying that HTTP 3 uses quick.
Yeah, and in fact, HTTP 3 is over UDP as far as I know. So it's even more problematic than HTTP 2. So before quick, we need to do something about UDP as well. So yeah, he's right. Victor's right. I mean, yeah, I forgot to mention HTTP 3 is a problem too.
No, it's a problem 3. Sorry, I couldn't resist. So Muhammad Shahid says it uses TLS 1.3, and then Victor agrees that quick is over UDP. We have a question coming from, there are characters that I do not recognize, so I'm sorry what I'll do now, but Dorte Sorgic, how do you solve client trust with a MIT box, especially at scale?
I couldn't understand the question. Is it in the
Okay.
chat? How
Yes.
do you solve client trust of a mitten box, especially at scale? Are you talking about the I guess he's trying to talk about installing CA certificate into clients, I guess. Or I'm not sure if he's talking about client certificates. But if he's talking about client certificates, then there is an option in SSL proxy where you can also supply a client certificate, certificate and key. But if he's talking about certificate forging and installing CA certificate into trust stores of all of those clients, then I tried to mention that we, for example, unfortunately, Firefox and Chromium, for example, have different places. You have to install them separately. And he's right. I mean, it's a problem for system and network administrators, but I think there are certain central management systems like MDM systems. But I'm not in the operations business, so I don't know exactly how they solve this problem. In large organizations, I understand that that would be a problem, but for example, there are, some organizations allow users to bring their own smartphones. Of course, that would be a huge problem for SSL inspection. You would like to create a new network for a guest network, for example, for them. So in large organizations, especially, that would be a problem if he's asking that question. And there are certain solutions, but that's one of the reasons why I think I mentioned this. System and network administrators are really, some of them are against solutions like SSL proxy and SSL inspection in general. I hope that answers this question.
Thank you. Please add more if the question was not answered. We have a few more things coming in through the chat. So Victor has said that, by the way, he has a very old SSL proxy header parsing branch that he's currently rebasing. Mohammed says that Active Directory environment can trust the organization CA and the domain joint system will accept it. And Aloysius Coelho asks, which currently commercial UTM support SSL proxy, like FortiGate, Palo Alto, or is it unique to Suricata?
Can you ask that question again?
It's in the chat, but which currently commercial UTM support SSL?
Oh yeah.
My mouth is not working today. I'm sorry.
No, I don't think anybody uses, or actually SSL proxy has a BST license, so you never know. I mean, but I don't think they need my expertise unless I'm sure they have developed their own solutions. But there is also SSL split, and SSL proxy is based on SSL split. Probably their solutions first started with SSL split. I'm the maintainer of SSL split as well, but I don't know, or I don't think those commercial solutions use SSL proxy.
Okay. Any more questions, comments, folks? I don't see any questions incoming right now. So I will share a few words for us to start moving towards the end of the webinar. But if you do have more questions, people, please just use the Q&A and we'll go back to them. So once again, thanks for the presentation and to everybody who has joined us today. In case you are not part of our community, please connect to us through the Discord server or our forum. Those are the best spaces for you to share projects you are working on, to ask questions, to discuss new future ideas before we move to Redmine, in that case of future ideas. The team is there. At least a couple will be checking, so it's a nice place to be. We've mentioned already, but if you can join us for PreSuriCon 2025 in Montreal, our agenda is live. There are still sponsorship spots available. And in the webpage, PreSuriCon.net, you also find more than 10 years of contents in our archives. If you can, we also have 3 different training sessions before PreSuriCon happening. We have crafting reliable detections or role writing. We have deployment and tuning, and we have threat hunting for investigating threats in depth. All of those are 2 days trainings, and we now have a easier way to get the bundled discount that you get when you buy PreSuriCon tickets and the training. You can see all of that if you go to PreSuriCon.net/trainings. We do have one more PreSuriCon webinar in October with Monsieur Eric Leblanc. We will be quite happy to see you there, October 16th, 2025, of course, at 2 p.m., just like today. Please register to be there with us. And that is basically all I had for today. I don't know if we got more questions because Zoom, I'll do this, then I can see. Yeah, okay. We are happy to see everybody around. Okay, I have one comment by Victor. Does anyone have some ICAP PCAPs? We have an issue on Redmine 6101, and I think this is for, I cannot do that now, but it's in the chat. I think it's probably related to ICAP support. If it is, usually for us to be able to support a feature, PCAPs are important. So if you do have PCAPs, folks, do share with us. The Redmine ticket 6101 would be the best place, but you can also use the forum if you lose the number. Anything else, people? Any last words in this webinar, Soner?
I'm happy to be part of this webinar series, and thank you for inviting again. Thanks for everybody. Thanks to everybody for listening. Thanks again.
We appreciate your participation. Congratulations on having such a long project that is still going. Thanks for
Thank you.
working on open source. Folks, I think we had a very successful webinar. If you do have follow-up questions that were not did not made up to the webinar, reach out to Soner. He has shared his GitHub. He's also on LinkedIn, our forum. So we hope that this conversation will keep going. And Aloysius says, thank you and really appreciate it for such valuable, knowledgeable webinar. I agree.
Thank you.
Thanks, folks. I guess this is it. Enjoy the rest of your days. I hope to see you all again in October, and I hope to see you all either in person or virtually for SuriCon as well. Bye all. Thanks. That's it.